Okay, here's what I'm working on today. This is a controller board the customer had, and he says, hey, there's some brown marks on this circuit board. It looks a little discolored here. And on the back side, you can kind of see we have, let's see if I can get in there. We have some problems with these traces here. So what I'm going to do is I'm going to go ahead and show you what I would end up doing for this rework. So I ended up buying some of these. These are 3 amp Inrush current limiters. They end up being 47 ohms when they're at room temperature, and then the inrush current happens and this device heats up a little bit and it goes down to a lower resistance, so it keeps the current from being high. It's an inrush limiter. All right, here's the first thing I'm going to do on these to take these out. Since the legs are so long, let me see if you can show. See, these things are actually spaced pretty far off the board, so we actually look really good on this. And one way of doing this is, come in here with your soldering iron and pull and pull. Now that's going to end up putting too much force on the pad that you're not working on. So it's fairly common in the rework world to go ahead and cut the bad component out. So I just got some dikes here. And also, by cutting it out, you remove this part that's actually going to be a heat sink for the part for soldering. Okay, so of course I don't have any tweezers. All right, well, I don't have any tweezers right in front of me, or needle nose pliers, or wait, there's some. Okay, got these crappy ones. All right, so this solder here might be Rojas compatible solder, so it doesn't have any lead in it. So the first thing as I do, and I'm just using a regular soldering iron, and this one's actually from a temperature control unit, but I used to do this a lot with my weller that I got in high school. So I have this thing set around 350 degrees, and I got a spool of this. I don't know what kind of solder this is, but I know it has lead in it because it melts really easily. I go ahead and heat this solder up here with the leaded solder, and that permits a lot more heat flow. And then I pull these legs out, these leads that are left in the board after that, and get that really hot so you don't booger up any of the traces on either side of the board. So it's just that easy to cut this out. I'll cut out this other one here. Can't hit the trash can with my burn up part. Yeah, there's a lot of crap on this board that looks like this board got pretty hot. Oops. Came through. There we go. I got it out of the other side. How handy is that? This one wasn't even soldered in very well. Okay, then I use this stuff here. This is called Tech Spray Pro Wick. I've done a lot of stuff with reworking in the past, and this stuff is awesome. This is part number 1802-25F. That means it's, I don't know what it means. Anyway, so I get this stuff. It's about 18 bucks, and I've used this particular one here for years. At some point I'm going to run out, but by looking in here, it's not going to be anytime soon. So I use this stuff to pull the solder out of these holes. So we're kind of clean up this board a lot. And by putting the lead solder in there, you get a lot more heat flow. So you're going to be able to heat up the board a lot more, and you're going to be able to pull that out. If you can't get it out, go ahead and put a little bit more solder in there. And this one has a lot of solder in it, so it may take a little bit of time to get this pulled out of here, and we may have to turn the board over and pull it out from the other side as well. Now what's going to happen when we do this board rework is that we're going to lift some of the solder paste up from the board itself. Not solder paste, the solder mask, the green stuff on top of the copper. And that stuff is, oh, look there, I got that one good. Okay, let's just keep going. Just didn't get it hot enough. Now if you look at here, there's a big piece of copper here. And look, I'm kind of scratching off the solder mask, which is okay. We can kind of clean that up later if we want. Looks like I got most of it off of the side, so I'm gonna spin the board over. These are pretty big traces, so they're gonna require a lot of heating. But on this side, you can see we got a lot of extra solder on this side, so we're gonna try to pull off as much with the soldering iron as possible. Okay, so that hole's pretty clean. So let's just keep going. So I'm gonna heat that up a lot, and then we'll keep working on this. Some people have vacuum pumps. I have one of those as well. I mean, the little handheld guy. And I also have my hot air rework station has a vacuum line on it. I don't like to use it. This is just a lot simpler. The vacuum lines are pretty nice though, if you get one that works, but they're kind of a pain to clean. This, when you're doing this soldering here, you can just cut this off and throw away what you've already used. Alright, now you can kind of see that I got this. There's a bunch of gunk on the back here. This is all burnt solder mask. So what I'm going to do is clean this up, and we will actually determine if these pads are looking pretty good. They actually look really pretty good. This one hasn't pulled off. That's the important part, because this is the trace here. Now, if this did pull off, what we would do is, since these pads are on both sides of the board, we'll solder the part in here and attach it to the board on this side. And then if this side of the board's copper is bad right here, what we'll end up doing is just hand wiring a trace from this pin over to this pin here with some type of, we can calculate the current of this, the width of this wire based on how, if we think this is 1 or 2 ounce copper. But we can put, not 18 gauge, like 20 gauge wire right across here and it'll be fine. Okay, so let me get this cleaned up and we'll be right back. Alright, I got this cleaned off here. What I ended up doing was I used a Q-tip and some isopropyl alcohol. And you can kind of see that I ended up scraping off as much of the solder mask as possible. And the alcohol left a little residue, so I just kind of wiped it off with a little towel. I got all that gunk off the back side so that it wasn't there. And I kind of just took as much of this solder mask off that I could with the Q-tip, and then I came in here and I scraped everything with my fingernail as much as I could to kind of pull off any last loose little parts. So this is what we're left with now. I see that there's a little bit of solder left right here. Some of you may be saying this stuff is too small for this type of work. It probably is. There's bigger gauge of this stuff, but it works out that well, I have this around because I do a lot of surface mount work on this side of the valve studio. And well, it's not the valve studio over here, it's my day job. And so I use something like this to pull the solder out of when you do bridge soldering for surface mount parts. Okay, so I got it all cleaned up, and so we're just going to put the new part in. So it's these MOVs. Just stick it in there, and this is the regular solder job at that point. And these guys were out at a certain point, about kind of, I don't know, 3/4 of an inch. And what you're going to see now is that your solder actually flows a lot more on the pad because there's no solder mask around the pad. Okay, so I'll let you take a look at that. See, there's a lot more solder here now. I'll tell you what I'm going to do here about you want to heat up both of these really well. Well, for this particular component, it's got really large gauge leads on these parts, and so I've soldered the top side. Now you want to make sure for this particular part, because these leads are so long, I'm going to go ahead and solder the bottom. We did have some solder come through on this one, but I'm going to go ahead and fill in this side as well. And this is a pretty big pad right here that I'm doing, so it may take a while for the solder to heat up this whole big pad, but it's getting there. Okay, so that one looks pretty good. I'll go ahead and do the other one, and I'm going to tell you how I'm going to insulate this. This particular circuit right here, where it runs on a, I think it's 2-phase 208. So we might be developing kind of a large voltage out here, and also is, you know, it's mounted inside of onto a stainless steel chassis. So we do potentially want to protect these bottom parts from, you know, short hazard to the chassis. Okay, I'm going to put this other one in. We'll take a look at that, and I'll show you what I'm going to use. Well, I'll show you what my options are. I think I have a pretty good option for this. Okay, I'll be right back. Alright, I got the other one soldered. So I have my 2 Inrush current limiters in. Now it's time to deal with the bare copper traces. So we'll go ahead and show you what I'm going to choose for that. A friend of mine came over about a week ago, and we were working on his quadcopter. He got one of these kits, and it's got a Pixhawk in it, which is an ARM4 processor running the R2 Pilot. And in his bag of tricks, he had servos and ESDs and ESBs and all that kind of stuff. What do we call those things? Speed controller? Whatever. He ended up having this called liquid tape. This is from a company called Gardner Bender, and there's 4 fluid ounces. I don't know where he got this, but I looked this up, and you can get this at Home Depot or Amazon for about $7. And the dielectric strength of this is 200 volts per mil, and a typical layer of this with this applicator is 5 to 7 mils. So we'll be up, oh great, we'll be up, you know, 800 or 900 volts. And so it's got this little brush, and what we're going to do is just kind of paint this on the bare copper things. We're going to leave the pads free though, so if there's future rework on this board, we'll be fine. Now, I guarantee you that's this layer, we may want to put this on with something that's not so gooey. It's probably well, it's gonna be okay. Let's do the other side with something a little bit more manageable. That thing was really supposed to put it on. So here, kind of take a look at what this looks like. Get this closed in here. Looks pretty good. On this side over here, I don't want to put that big brush in there. You should get it all over the top here and it won't look too good. So what I think I'll do is use a piece of wire. Let's try this and see if I can get enough of this out. Looks pretty good. So I'm just going to paint this on the spare traces, the exposed traces, and it's going to do both insulation as well as protection to keep those copper traces from oxidizing. So I'll paint this up and I'll be right back. Alright, so I used a Q-tip and I was able to pull a lot of the extra stuff off, and then on this side I used a little piece of wire and I kind of just painted it down there. This stuff here has got a consistency of like tar, like, you know, really thick tar, and then it sets up really quickly. Probably been about maybe 5 minutes since I did this side, and you can kind of see it's getting dry. The bottle says you have to let this dry for about 24 hours, but I think it's going to be a lot faster than that. We live in a pretty dry climate right here. So this looks okay. I did have to clean this up a lot because, you know, this is a customer's board, and didn't want it to look like crap when I give it back to them. but this side over here is the important side because the board sits down like this, and this is the steel chassis. So we do have now, you know, some insulation, as well as protection for the copper traces. Okay, well, thanks for watching. Hope you got something out of this. Good luck with your reworks.